when I finally lay my eyes on you.
आज हम करेंगे लीड कोड पे करके एक या दो क्वेश्चन सॉल्व हमेशा की तरह।
Will it be a
ठीक है, let's start the stream. Hey everyone. Um, so the first thing that we're going to do is that we are going to solve our daily problem. Today is day 7. Let's solve the 7th problem right now. It is an easy level problem. You have to construct a string from a binary tree. Given root of a binary tree, I have to construct a string consisting of parenthesis and integer from a binary tree with a pre-order traversal and return it. So pre-order traversal, what is a pre-order traversal, by the way? A pre-order traversal is when I do root left right. Is that it? Pre-order traversal, I think it is root left right, I'm not sure. ठीक है, pre-order traversal, it is visit the root. The pre-order traversal is 1 2 4 5 3. Now yeah, so it's root left right. Now I have to construct a I'm supposed to construct a string from this binary tree. The string would look like this. How would it look like this? 1, then I go to the left side and I go to the right side. When I go to the left side, I write the value, then I apply the parenthesis and I go to the left side and I go to the right side, something like that. So my thought process says that my answer could be a array, for example, and I might just return that array. Now I can say pre-order of root. I can also say if root is none, in that case you just return. Otherwise what you do is that you have temp, which is string of root dot value. Alright, now what you are gonna do is you're gonna return, let's say you're gonna go to left, which is pre-order of root dot left, and you're gonna go to right, which is pre-order of root dot right, and you're gonna say if okay, so now I need to put whatever I got from left inside of a parenthesis. If left is not none, which means if left is there, then my temp would be, let's have an opening bracket plus string would be returned by the left plus a closing bracket, and if right is there, then the same thing, like this plus right plus this. Okay, if it isn't here, then I'm just gonna say none. Anyways, so this is my temp and I'm going to return temp. I might just say pre-order of root. Let's see if that's gonna fix anything, if that's gonna give me the correct answer. Let us check for all the test cases just to make sure that it's actually working. So this is my temp. It isn't. So the problem is that I don't have an empty thing, except we cannot omit the first parenthesis here to break the one-to-one mapping relationship between input and output. This is weird, because I cannot break the one-to-one mapping between the input and output. Okay, okay, cool, I get it. So I have to add this if left or not right. Does that make sense? If left and not right, then I would return this. Uh, hmm. If left or, so if left is there or if right is there, in both of the cases you have to append left. But if left and right both are not there, then you can omit, and that's it. Okay, let's see if there's a hard level question. No, there isn't a hard level question. We are on 7-day streak, which is a very nice thing for us. Let's see, we do not have a hard level question here, so we'll just go to the Amazon sheet and we are going to solve the question called max value of equation. It is a hard level lead code question, so it's gonna take some considerable amount of time. Let us start a timer this time, and what we're gonna do is basically we're gonna calculate how much time does it take for us to solve this question, or maybe come up with a decent approach for this problem. So now the problem is you're given an array points containing the coordinates of points on a 2D plane, okay, by x, sorted by x values, where points of I is this such that xi is less than xj for all ij, okay, for all you're also given an integer k. Return the maximum value of the equation yi plus yj plus mod of xi minus xj, where mod of xi minus xj is less than equal to k. Mod of xi minus xj is less than equal to k. So I can come up with a O(n) square solution. That is a very easy solution. I can come up with a O(n) square solution, but I don't think O(n) square would be accepted because of the constraints that we have. So we'll have to improvise a solution a little bit. Let's see what are the things here. So you're talking about the max difference between the xi minus xj, but that is mod, plus then you're summing the yi and yj. Now you want this xi minus xj to be less than equal to k. So if you are on first position, what you can do is you can say k minus 1, right, and 1 plus k. If both of them are, if any of them is in the hash map, then you extract that and check for the answer possibilities, right? Then you go to the next one, then you once again check if k minus 1 or 1 plus k is in the hash map, and you check for the possibilities. My question is, if two xi are going to be equal? No, they are not. Xi forms a strictly increasing sequence. So can I not simply have a hash map and I can say for point in points x comma y is point. Now I want to have a hash map of x, right? I want to save this. I want to say hash map of x contains the entire point. I can create a hash map because this is a strictly increasing sequence, so I would never have x repeated for me. Also so I have to return the maximum value. Let's say this is answer, and the maximum value, we're going to consider the maximum value to be negative infinity. Hi Chirag, hello, long time no see. Where was I? I have the answer now. How are you, Chirag, by the way? How are you? Um, for the question, I will once again loop maybe, and what I'm going to do is I'm going to say if k plus, so let's say we're going to extract x comma y from point, and I'm going to say if x plus k, so if that is in hash map, if hash map dot get x plus k comma minus 1 is not equal to minus 1, then I have tx comma ty as hash map of x plus k, right? And in that case I can say that answer is maximum of answer comma absolute of oh, that's why it is a hard level question. So I was wondering, why is it a hard level question if it can be solved just like that? The thing is that we have been given that xi minus xj absolute is less than equal to k. If it was just equal to k, then this question was very easy to solve. But since I have it as less than equal to k, I need to know how many x do I have which have a value, which have some given value y. So let's think for a minute. Let's think what could be the possible possibilities. Let's just consider the x value 1, 2, 5 and 6, and the k value is 1. So now I want the maximum difference. So I have to find out which are the points in this array which are having the maximum absolute difference from this number as k less than equal to k. And I don't want to do O of n square, although that's a easy approach, but I do not want to involve myself in O of n square. I have an observation. The observation is that if there are two numbers a and b and c, and I can say that a plus k, or I can say that b minus a is less than equal to k, then when I go for b, I once again check for a. I can skip that, but there would be other number c, for example, which will have c minus b less than equal to k, but c minus a is greater than k. So is there a way that I can get all the numbers from this one only? Okay, let us think for a couple of seconds here and try to figure out what could be a possible solution. I'm just going to write down random stuff on copy for now. Let me try to come up with a nice solution. Okay, so you're given an array points containing the coordinates of points on 2D plane. I have an observation right now. The observation is that, for example, if I have a case where, let's say, so I'm going to explain the observation. Okay, the observation is very simple. The observation is such that if I have a case, let's say I have A, B, C and D, and I can say confidently that C minus A mod is less than equal to K. In that case, like if I can say this, then I know that B minus A would definitely also be less than equal to K. The reason being, B is smaller than C but greater than A. Is that true? Is that true? It looks like this is true, but is that true? So let's take some numbers. For example, 1 2 3 5, and I have 1, and I say that if I know, let's say if I have 2 less than equal to 2, right? So the maximum difference can be 2. The maximum difference would, if the maximum difference is K, then definitely this is less than maximum difference. So this is true. Yeah, this is true. Now if this is true, what I can do is, I know that if this is true, then I should always take this. I should never take this one. I should never take the numbers that are in between. I should always take this one, because this is going to have the maximum value of y also, because since this is a sorted this is an array that is sorted in strictly increasing manner. So my approach says that when you are on a number, you check on its left and right and use bisect. You check what is the biggest number that still satisfied that property, and once you find that number, you update your answer. So this is going to be n of log n. So my time complexity is going to be O n log n, and I will have to use bisect to do binary search, and I will do bisect on every number. So this would be O of n times bisect timing is log n, so O of log n would be the solution. So now, since we know what to do, let's quickly try to solve it. But at the same time, I do have to spend some time revisiting the bisect actually, because I'm not familiar with bisect Python. But I have a feeling that this could be solved just using the bisect. So when I say bisect from an array and a number, I give a number, then it returns me the rightmost index to insert, so list remains sorted. So when I say 4, the answer comes out to be 5, which is 0 1 2 3 4 5. So the rightmost index. Okay, let's not get ahead of ourselves, and let's try to figure out the solution. My answer initially is minus infinity, and I'm going to return answer. Now I'm going to say for point in points, or maybe I'm going to say for index in range length of points. Now my x comma y is nothing but points of index, right? Because this is my current point. So I have my x comma y set up for me. The next thing that I want to know is the two possibilities. The first possibility is check the right half for, so in the right half the x dash is gonna be greater than x. So I can say that x prime minus x less than equal to k. And the second possibility is check the left half, because this is an absolute value, so I have to check the left half also. Check the left half for x minus x prime less than equal to k. Okay, so this right half is nothing but index plus 1 to length of points minus 1, this much, and this is going to be 0 to index minus 1. Now for this case, the array would be points of index plus 1 till the end, and here the array would be points of from starting till index, right? Now right here I want to find the large, so I might say that cur or the next, let's call it next. Next is going to be x dash minus x is less than equal to k. So I need to find x dash, that is k plus x times. So I need to find a number in the right half of this array such that it is less than equal to this. Okay, and let's see what this is doing. If I go to bisect right, rightmost index to insert, so the list remains sorted, which means so it is taking multiple things, number, beginning and end. Okay, that's fine. This is not something that I'm really worried about right now, but this remains. So for in this case, when I wrote for 4, it returned me the fifth index, because the fifth index, on the fifth index for the first time the number was higher than the given number. So the given number is k plus x, right? So when it returns the number that is higher than the given number, I will just go to one back position. So what I'm going to say is, I'm going to say that pos is bisect dot bisect dot bisect for points index plus 1 till the end. Should I do index plus 1 till the end? Yes, it would be fine. And then I'm going to say next, and whatever pos I get, I have to do pos equal to, so I have to add numbers up till this index, right? So if this is 4, then yeah, so I have to do this minus 1. So I might have to do this, right? Now I'm not sure if this is correct, but anyways I'm going to print the position, right? So let's go to the first case, and what I'm going to do is I'm going to break after this. So this should return me 2, which is 1. This should have 1, but it says that this is not supported between instance of int and list. This is totally fine. I can create x list as x for x comma y in points, and I can say bisect the x list. Sorry for the noise. It returns me 1, which is not the correct output. Let's not break, and let's see what it returns for everything. So in the first case, it returns 1. So I need to insert at position number 1, or I can say it returns 1, which means for 1 k plus x, 1 plus 1 2 is this. Now I do the same thing for the next number, and this time my k plus x becomes 3, and I do not have 3 in the array at all. So the first digit is of course greater than 3. So it returned, so the index becomes the pos is equals to the current index, and if that's the case, then we would just simply like we can ignore the parts, right? That is fine. The next thing is for this one, this returns 3, which is fine, and this also returns 3, which is also fine. So now what I can do is, can say if pos not equal to index, my pos is not equal to index, right? In that case, I will have to update my answer as maximum of answer comma. So now I know the position, I know the exact position that I want. So I would say that the correct answer is points of, so it's gonna be y plus points of index of 1, right? plus absolute of x minus points of index of 0. Got it? So this is when I just check in the forward direction, and I'm not even checking in the backward direction right now, though I might want to check in the backward direction also. So it is creating some sort of problem for us. I don't know why. Pos not equal to index and pos less than length of points. Print pos comma points pos comma x comma y. Let's also print this thing. Yeah, so the pos is 1, the correct is 2 comma 0 because it is less than equal to this. The point is 1 comma 3, so it is going to be 1 plus 3, right? It's just fine. I might want to print answer here just for the sake of clarity. Answer comes out to be 6, which is not the correct answer. The correct answer is points of index, no, points of pos. So this is where I was wrong. Points of pos is the correct thing to do right here, right? Now this is happening when I'm checking for the right half, but mind it, do I need to check for the left half or not? Do I need to check for the left half or not? I'm not sure. So the best thing that I can do right now is to check for the left half also. I'm going to call it prev, and prev is going to be, so once again, if you go here and you check this out, the prev is nothing but, it is gonna be so it is gonna be the current one, which is xi, right? The current one minus k. So current one, it is going to be ki minus kp less than equal to k, xi minus xp less than equal to k, and this proves that my xi is supposed to be greater than equal to xi minus k. So I'm just going to say this is nothing but xi minus k, which is x minus k, right? And now I have to find the number which was just greater than equal to xi minus k. Okay. This time it was less than equal to, but now I have to find a number which is just greater than equal to. So when I say bisect left for 4, it returns me 2, which is 0, 1, 2, which means for the first time the 4 or something that is less than equal to 4 is occurring at this, greater than equal to 4 is occurring at this. I want to find something that is greater than equal to prev. When is it occurring? So this is nothing but pos equal to bisect dot bisect left, right? The function is called bisect left. Bisect left for x list of 0 till index comma prev, right? And whatever it is going to return to you would be your correct position. Okay, but in a case, so let's just print this first just to get clarity first of all, and then we will check if it is correct or not. So first of all, my concern is that it is printing too many things. Is it? It is printing too many things. Do I have another print statement? I do not. Then why is it printing too many things? That's a good observation. Yes, because we have two different test cases that we are running simultaneously. That's why it's printing too many things. Anyways, so I once again have to do the same thing, which is if pos not equal to index, right, and pos is greater than 0, greater than equal to 0, then I can say this exactly same thing, that my answer will be maximum of this. And now I can run the code, and now I can sort of believe that this code is going to be my solution. But I'm still not sure if this is my solution or not, but I would say that this is my solution. Let's see if it gives me a time limit error. There's a high possibility that I'm going to get a time limit error, but no, it gave me a wrong answer because it gave me a wrong answer. So for the first approach, it took us 24 minutes. Now let's see how much time does it take for us to move to a second approach. It gave me a wrong answer. Now I do not know why have I got the wrong answer. The correct answer is 41. Yes, and the k value is 5. So a digit having a difference equal to this. Should I just remove this? Should I or should I not? I'm still getting my answer as 39, but I'm supposed to get my answer as slightly better. Why am I getting a wrong answer here? Let us check if we were actually doing something that makes sense. No, we were not, because it was supposed to be solved using queues and sliding window and heap. Has anyone tried this using, okay, so maybe that approach would give you O of n time, but I want to understand if someone tried it using n log n time complexity, but it I did miss something very obvious right here. I did miss something really obvious in this question. And the thing that I missed was, so that would change my approach slightly, definitely it will. If I use a heap, I can create a O and log n. I'm just trying to figure out if someone actually wrote the code using binary search and stuff. I doubt if someone has done that, because it wasn't so simple to come up with a weird solution. But anyway, so I did miss something really obvious here, which is, since I know that I is less than equal to I is less than j, so I know xi is always going to be smaller. So I know that yi plus yj, and this is going to be minus xi plus xj. So this is always going to be yi minus xi plus xj plus yj. So I always have this y minus x, and I always have x plus y. So what I can do now is simply what is the I'm not looking at a O of n solution right now. I'm looking for a O of n log n solution, which is this. Now we can calculate yi minus xi and store it in a priority queue along with xi. Okay, priority queue, because we will get the maximum value on the top. We will iterate over elements, and if top x in the priority queue and current x have a difference greater than k, we will pop that out. So if the top x in the priority queue and current x has a difference greater than k, we'll calculate the equation. Let us search for some Python explanations for this problem. Max value for equation. Maybe we can go on YouTube and have a look at this solution. Someone might have solved this. So let me increase the volume for you. Max value of equation. Let's search for this.
Hello everyone, welcome back to Lead Coding. On this channel we discuss problems which are frequently asked in many smaller than or equals to k. So this is what we have to do. y1, x2, y2, x3 and y3. So these are the 4 points. Now we are sure that x1 is greater than x0, x2 is greater than x1 and x3 is greater than x2. So it is sorted on the basis of x coordinate. Now when we are comparing 2 points, let's say the first and the second point, the first condition that we have to check is the difference, the absolute difference in x. So the absolute difference in x is nothing but x1 minus x0 because it is sorted. Now looking at the equation is yi plus yj plus xi p x of j y of j plus, we are at the jth index, we simply have to add the x and the y coordinate, and then from the
Hey, what's up, guys? Value of this equation. I mean, of course. And remember, okay, so one more thing here. Since in Python, there's the priority queue, there's only like a mini priority queue here. There's no built-in.
Q4, max value of equation. So part, and it is not easy, is recognizing that, so one is that the x are sorted, so I like this. Oops. Is that, even though this formula is like this, oops. I think that's the part that I struggled with a little bit when I was looking at it. So you have this formula, but actually since I is less than j, and we were told that x of I is less than x of j, you can actually rewrite this as x of j plus x of j minus x of I, right? And then now, from that point, you can separate out to x sub i's and the x sub, you could separate out to j's, so that looks like this, plus this, right? Yeah, and you know, so here, so now you have this element as you go from left to right. using a mono queue or a monotonic queue or a max queue, right? So now you're given this number and a max queue. All you have to do is take the max element and then add it to the current element, and when you put it on the queue, just put this sum back in, and that's how you do it. The implementation may be a little bit tricky. Again, check out my mono queue video. I didn't even solve it that way. I did the mono queue, but I did it with a heap because I wasn't quite sure why I was solving it. There are a couple ways to do it. I always describe this way of solving it on that mono queue video, so check it out. But yeah, but now that you've written it this way, this is the thing that you're trying to get the max, and as soon as x sub j minus x sub I is greater than k, you remove it from the mono queue, and that's how you solve Q4. Pretty straightforward once you do this formula manipulation. It took a little bit long because I didn't make the connection, but yeah.
What the hell, he didn't even explain. He said that it's pretty easy for you to do, so कर लो जाके. So for each pair of j, we have j, and we only need to find out the maximum of this. To find out the maximum element in the sliding window, we can use priority queue or stack. ये कैसे किया है? तो एक क्यू बना ली, res इक्वल टू, ठीक है, फॉर एक्स कॉमा वाई इन ए, वाइल क्यू एंड क्यू के टॉप पे जो फर्स्ट एलिमेंट है is less than x minus k, then you pop. If you still have q, then जो q के टॉप पे एलिमेंट है उसको x के साथ ऐड करके y के साथ ऐड कर दो. And then heap q dot heap push q comma x minus y comma x. ठीक है. ठीक है, सॉल्यूशन समझ आ गया, but it was slightly not so obvious to me somehow. पर इसमें काफ़ी इंटरेस्टिंग चीज़ें लग रही हैं, तो मैं इसको लिखूँगा because this is a very beautiful problem. Again once again इसमें बहुत ही इंटरेस्टिंग सी चीज़ लग रही है, और वो है कि स्टैक का कितने प्यारे तरीके से यूज़ किया है. बहुत अच्छा है. शीट में इसको रेड मार्क करते हैं बिकॉज हमसे तो सॉल्व हुआ नहीं. आजकल हमसे वैसे भी आई डोंट थिंक हमसे एक भी क्वेश्चन सॉल्व होते हैं, बहुत ही रेयरली हो रहे हैं. वी आर नॉट इन अ गुड शेप राइट नाउ, बट आई डोंट ब्लेम एनीवन फॉर इट. इट्स जस्ट दैट इट इज़ व्हाट इट इज़. आई एम गोइंग टू से माय हीप इज़ h फॉर नाउ. लेट्स जस्ट से इट इज़ h. For point in points, okay. I have x comma y as my point, okay, and just give me a second. I have x comma y as my point, and the next thing that I want to do is I want to say while heap is there, let's just call it q instead of heap because q is a better name. While q is there, and if I go to the top, so what is the top? 0. If I go to the 0th and I check the first and I say if this is less than x minus k, which means, remember, I know that xi minus xj is less than equal to k. So if xi minus xj is greater than k, right? This is xj and this is xi. xi मतलब बड़ा, ये छोटा वाला, ठीक है. If this is the case, in that case I'm going to say heap q dot heap pop q, ठीक है. Once I'm done, if q is still there, then I'm going to say answer is max of answer comma heap q dot heap pop, let's not pop, let's just say q of 0, and I'm going to negate this shit and I'm going to add x and y to it, right? Anyways, I'm going to say heap q dot heap push q comma so that is supposed to be y minus x. I'm gonna say x minus y comma x, ठीक है. X because I'm checking x here. If you no matter hip hop, I'm just going to add one more p and I'm going to assume that this is going to solve my problem. See, even though it was a hard level problem, all it took was barely 6 lines of code, and that's the beauty of hard problems. They take less amount of code. Count pairs into array. No, I can't solve it, which means I'm going to end the stream right